Welcome back everyone. Today we will be learning about composite functions. So a composite function basically means that two or more functions are combined together. This diagram shows us an example of a composite function. We can observe that there are two functions, function f and function g. There are also three sets of values, which are x, y, and z. So function f has object x and image y, while function g has object y and image z. The two functions can be combined to obtain function gf, whose object is x and image is z. Notice that when you combine two functions, the first function is always written on the right. Based on the diagram, we can conclude that function fx is equals to y and function gy is equals to z. Since y equals to function fx, function gy can also be written as function g with object of fx is equals to z. From the diagram, the composite function gf with object x is equals to z. Hence, we can conclude that function g with object fx is equals to function gf with object x. Now here are some important rules to take note of. Function gf is not necessarily equals to function fg. Also, if a function is repeated, for example, function ff, it can be written as function f squared, and if function triple f, then it can be written as function f cubed, and so on. In the first question, we will be taking a look at how to express values in terms of x. Now in this question, we have function f and g, which are defined as fx is equals to 6x plus 5 and gy is equals to 3 minus 4y respectively. So we have to determine the value of y in terms of x and the value of z in terms of x. Now from the diagram, we know that function fx is equals to y. We also know that function fx is equals to 6x plus 5. So after substituting function fx, we get 6x plus 5 is equals to y. And after inverting the equation, we get y is equals to 6x plus 5. So this is our value of y in terms of x. Now let's find the value of z in terms of x. So from the diagram, we know that function gy is equals to z. We also know that function gy is equals to 3 minus 4y. So let's substitute that into the equation, and we get 3 minus 4y is equals to z. Invert the equation and we get z equals to 3 minus 4y. And earlier we have found that y is equals to 6x plus 5. So let's plug that into the equation, and after expanding we get 3 minus 24x minus 20, which gives us negative 24x minus 17. Now let's take a look at a similar question. So this example differs from the previous example as function g is defined in terms of object x. So the two functions are defined as fx is equals to 4x and gx is equals to x minus 2 respectively. So we have to determine the value of y in terms of x and the value of z in terms of x. So from the diagram, we know that fx is equals to y, and we also know that fx is equals to 4x. So this gives us 4x is equals to y, and after inverting the equation, we get y in terms of x. Now moving on to part b, we know that function gy is equals to z from the diagram. Now in the question, we are given function gx is equals to x minus 2. However, we are able to change the object of the function from x to y. That gives us function gy is equals to y minus 2. So let's substitute that into the equation and we get y minus 2 is equals to z. Invert the equation and we get z is equals to y minus 2. And previously we have found that y is equals to 4x. So our final answer will be z is equals to 4x minus 2. Next, let's take a look at how to find composite functions. Given fx is equals to 2x minus 3 and gx is equals to x squared plus 4, find the composite function of fg, gf, and g squared. Now it is important to always start from the right when solving composite functions. So let's dive into part A. Now if you recall earlier, we have learned that you can make the function on the right the object of the function on the left. So in this case, function gx becomes the object of function f. So after substituting function gx into the equation, we get function f with object x squared plus 4. So now we have to put the object x squared plus 4 into function f. And that gives us 2 open bracket x squared plus 4 close bracket minus 3. So after expanding, we get 2x squared plus 8 minus 3, which gives us 2x squared plus 5. For part B, we need to repeat the first step. After that, we substitute the value of fx into the equation, so that gives us function g with object 2x minus 3. Now put the object of 2x minus 3 into function g, so that gives us open bracket 2x minus 3 close bracket square plus 4. After expanding, we get 4x squared minus 12x plus 9 plus 4, which gives us 4x squared minus 12x plus 13. Now to solve function g squared, make function gx the object of function g. Then substitute the value of gx into the equation and we get function g with object x squared plus 4. Now put the object into function g and we get open bracket x squared plus 4 close bracket square plus 4. After expanding, we get x to the power of 4 plus 8x squared plus 16 plus 4, which gives us x to the power of 4 plus 8x squared plus 20.